I know tangent, cotangent, those guys are reciprocals one another. It's probably forcing me to try it into a common denominator. So if I try to set up a common denominator on that one, I believe this one here. You sound healthy. Sorry. So this gives me sine, cosine plus cosine sine. I'm just going to do this to bring it over. Sine squared, cosine squared, over cosine sine. So far, so good? Secant squared is 1 over cosine squared, so I'm going to rewrite that. Sine squared plus cosine squared is 1. Multiply out by the reciprocal. And we get what? Cosine. Oh, this should be just over 1. I'm sorry. I just got a little crazy. Cosine over sine, which is? Is basically the same thing. 41, distribute. How many terms are inside the parentheses? 2, not 3. You're supposed to laugh. I know.
The joke is that you're the joke.
Tough crowd.
First of all, if it was a joke, it's going to be named on the side first.
Yeah. When you multiply reciprocals, what do you always get? 1. So the cotangent, cotangent, tangent go away. So I have cosine plus cosine over sine times sine. Uh, 42, just get a common denominator, because you'll get sine plus cosine squared over sine, which therefore gets you sine squared plus cosine squared over sine cosine, which just gives you secant cosecant. 43, there's a couple of different ways you can go about it. Some people have tried to rewrite the secant plus 1 in terms of sine and in terms of cosine, get common denominator, do a complex fraction. But what's tangent squared? Secant squared minus 1. So that's secant squared minus 1 over secant plus 1 plus 1. Is that a perfect square? Is 1 a perfect square? That is a fraction symbol. Factor it. Secant plus 1, secant minus 1, over secant plus 1, plus 1. What's secant minus 1 plus 1? There's not one way that every one of these works. That's the problem. You guys have to understand that you have to work your way through them. There is no one size fits all, do this the same every time. This is not a replication style problem. Like I said earlier, this stuff is hard, okay? It takes time to work through. You're going to struggle. If one method isn't working, try something else, okay? And that's the idea here. Not the idea of making it struggle. Let's see. 44, again, that one's going to wind up being a giant common denominator problem. I'm just going to rewrite right away. I get 1 over cosine, 1 over sine, over 1 plus sine over cosine. I'm just creating one giant complex fraction right off the bat. Get common denominators and things go real quick. You get sine plus cosine over cosine sine over cosine plus sine all over cosine. Take the bottom, flip it up. Cosine you gotta keep cosecant because then you get 1 over sine. Let's see, 45 is what tangent, 1 plus secant. Okay. But since you're adding two fractions together, this gets really messy if you try to do two separate complex fractions. I would probably just, what I'm thinking is I would probably just try and go and get a common denominator and go try that first. Okay. If you try that first, you're going to wind up with tangent squared. Plus, if I FOIL this one, I'm going to get 1 plus 2 secant plus secant squared all over 1 plus secant tangent. Okay, common denominator. I just multiply tangent by tangent and then 1 plus secant times the 1 plus secant. I FOILed it out. Okay. Now, at this point, I know, bless you. Remember, bless you. If you guys know this, if you know that, you can generate the other two identities easily. The first one is created by dividing everything by cosine. What's cosine divided by cosine? What's sine divided by cosine? I'm sorry. Yeah, sorry, I was getting ahead of myself. Sorry. The other one works when you divide it by sine. Okay. Now, as I go through some of these things, I have a whole bunch of stuff. Okay. If I rewrote secant squared in terms of tangents, that would wind up with two tangents and it doesn't look like it gets me anywhere. If I rewrite tangent squared as secant squared minus 1, at least I might get rid of one of the secants and it leaves me all secants in the numerator. Do you see that?
Yeah.
It's worth a shot, right? So I have secant squared minus 1 plus 1 plus 2 secant plus secant squared all over. I'm just going to leave it like that for right now. Okay. Right, because it won't be able to simplify out because of all the other addition parts there. So, but what I would do now is combine my like terms. Then I can get terms to factor. Okay. So when you combine your like terms in the numerator, the ones go away. 2 secant squareds, 2 secant. Where's the 1 plus? Okay with that? What's the GCF of the numerator? GCF. Yep. I love how you guys are. You can do that. All right. All right. So one last time. split apart the fraction. Okay, rewrite. 1 over tangent's cotangent, correct? So that's cosine sine. So it's 2 over cosine times cosine sine. Final answer is 2 cosine. It's 2 secant. Secant's 1 over cosine. So I'm rewriting, when I get to the very end there, I'm rewriting things sines and cosines, secant and cos. So I wind up with 2 over sine. .46 is very, very, very similar to that. Bless you. That was fun.
That was long. There's a lot of
Cosine plus tan, or plus sine squared yes, ma'am. Simplify, verify. Simplify, verify. Fully everything out. Cosine squared plus 2 cosine sine plus sine squared plus cosine squared minus 2 cosine sine and then plus sine squared. Foil it out. Junk squared is junk times junk. Foil it out. Remember patterns. You get first term squared. Multiply the two together. Double it. These go away. What's cosine squared plus sine squared?
1.
What's cosine squared plus sine squared?
1.
Plus 1 plus 1.
2.
Uh, 48's kind of like that also. Let's see. Verifies. So verifies here. You have 1 plus cosine over 1 minus cosine. Switches to secant plus 1, secant minus 1. Okay. Now, in this case here, first thing you might think of is doing a conjugate. If I multiply by a conjugate to the 1 minus cosine, you had to multiply top and bottom by 1 plus cosine. That would give me a difference of squares, which would give me basically 1 minus cosine squared in the denominator, which is sine squared. Sine squared is not going to get me anywhere near secant. So when I see that it's just going cosine secant, there's no squares, rewrite common denominator with the reciprocal function. This is the same as saying 1 plus 1 over secant over 1 minus 1 over secant. Get your common denominator. You get secant plus 1 over secant, secant minus 1 over secant. Bubble flip. Bring this one up. You verify. Good times that about. You can ask anybody that's been in this class, this is the worst section of the second semester. We did 50 in class yesterday.
Where did you get the second secant?
What second secant?
Like, if you put secant plus 1 over secant,
Yeah.
where did you get this secant?
Common denominator. Get a common denominator between here. It's got to be secant. That's 1 over 1. Multiply this by secant. This one has a secant. So secant plus 1.
Yeah, okay.
Common denominators. Yes, sir. I rewrote cosine as a secant. 50 yesterday. 51 is just a FOIL. It's a FOIL common denominator one. 52. On 52, I think was the one that you have to go right to left. I was looking at that one, and there's really no easy way to split that one out. I'm pretty sure 52 has to go right to left, and I think that's the one I forgot about here. So let's see if I do right to left on this one. This is 52. I'm going right to left on 52. I promise everything that I give you guys on any form of assessment is always going left to right. I think this is the one on the sheet, and I always forget this every year to make a note of it. I think this is the one that's supposed to go right to left. So let's see what happens when you go right to left on this one. What I would do is just FOIL it and see what happens. Let's see, I get tangent, tangent cosine, tangent sine, cotangent cosine, and cotangent sine. After I do that, I'm going to rewrite sine, everything in sines and cosines. Okay. So this is sine, cosine, cosine, sine, cosine, sine, cosine, sine, cosine, and cosine, sine, times sine. Within each one of those, I'm going to do a little bit of simplifying. Okay. First and last terms, this cosine and sine drop. So I have sine plus sine squared with cosine plus cosine squared over sine plus cosine, because these guys go up. So far, so good. Adding fractions, they have to have what? Common denominators. Now, as you see, when we wind up with a common denominator here would be cosine sine. Oops, sorry, I'm going to go too far there. First fraction needs them both, doesn't it? So I have sine squared cosine. Okay. Second one needs a sine. The next one needs a cosine. Oops. And the last one needs them both. Okay. Let's see. If we group them separately, will that help us any? Group those. We have a bit of a problem. We would call this a bit of a pickle.
I was thinking that one.
Oh, duh. Hey, are these two the same? Yeah. All right, factor it out.
Oh, wait.
What's that? One. Okay. So now we're at cosine plus sine over cosine sine, which means they have a common denominator, which means you can write two fractions. And there you go. I knew we'd get there. I just had to stop and have a sip of coffee. So that's 1 over sine, 1 over cosine.
Which is other way around, yeah.
That one sucked.
It wasn't that bad.
We just forgot about how to do math when you foiled out.
Really clamped shit down.
See, I saw that.
No, please say something. I blind scroll fine tonight. I mean,
Like you're blind.
and every once in a while,
You find the answer.
a broken clock is right twice a day.
Unless it's a digital clock, then it's right.
Unless it's flashing at midnight,
That's right.
which could be twice a day. Alright, that was fun. 53, I think 53 is the one you want to do, go to cotangent. If you go conjugate, I don't think it's going to get you anywhere. I believe 53 is another one you'd split right off the bat and go to 1 over cosecant over 1 plus 1 over secant. The reason why I'm saying that is if you look at what they're trying to verify you to, they're verifying towards reciprocal functions. Okay? So if I rewrite it right off the bat, it might get me there. Now, we did one like this a minute ago. This was secant plus 1 over secant. Correct? So, we just have to come up and flip. Oh. No, it's an addition symbol. So if you do that, so we get what? Secant over cosecant, secant plus cosecant. Cosecant, secant doesn't really get me anywhere. I don't think it gets me there either. My notes on this. I don't look at my notes. I don't know if that gets me for some reason. Try the other way. The other way I was thinking of trying on this one is, sorry, it's 1 plus cosine. I thought I was trying that way first because I saw reciprocals. If I do a conjugate here, let's see what happens if we do a conjugate. When you do a conjugate in this case, you get 1 minus cosine squared in the denominator. So that becomes the sine squared. Numerator, you get sine minus sine cosine. Oh, this was the way to go.
Where do you get sine?
I distribute
Yeah.
sine times 1 minus cosine. I'm just
No, the sine squared.
this is 1 minus cosine squared, which is sine squared. Now I have a common denominator, split it, and then it works. I should have gone this way first. That was a lot easier.
So what's the sine?
So I struggled wrong. So this is cosecant minus cotangent, and you're done. I should have stuck with my gut and done the conjugate right off the bat instead of trying to get all fancy schmancy with it. Oh well, you live and learn. Thank you. Encouragement. Let's see, 55. I would try the same thing with 55. Looks like I would go another conjugate on that one. You do that because then you get 1 plus cosine over cosine squared. Yeah, that should make itself work on that one. If you go conjugate. 56. 56. So it's secant minus 1 over tangent, and I want this to be tangent over secant plus 1. If I'm looking at this right off the bat and I'm seeing that I've got 2 terms in the numerator, 1 in the denominator, I might just try to split it right away, see what happens. Worth a shot. So you have secant over tangent minus 1 over tangent. In this case, split them up here, we'll wind up with 1 over cosine over sine cosine. So that's cosine over sine. So the first fraction winds up being 1 over sine minus cosine over sine, because 1 over tangent is cotangent. So then I get common denominator, and I'm already there with 1 minus cosine over sine. But that's not secant tangent, is it? Okay, so second try. Maybe multiply by a conjugate from the numerator. See what happens there. Sure. It doesn't change anything, does it? It's numerator denominator. You're still multiplying by a factor of 1. Okay? So my first attempt there didn't look like it was going to work, but if I try it this way, I do secant minus 1 tangent. It's worth a shot, right? My numerator now becomes secant squared minus 1, doesn't it? My denominator is tangent times secant plus 1. Huh. What's secant squared minus 1? Tangent squared. And we're done. At 1 over 3. Yep. So it works itself out that way. I didn't even think about doing that, but I guess it's worth a shot. So things that I've kind of picked on, not like picked on you, I'm not like literally picking on you, but picked up on, I should say, is that we have mental blocks when we see these things because we're not sure how to start because every starting point's different. And the reason why I wanted to show you guys that it's okay to struggle through these things, because that's fine. You'll notice I tried one way and I'm like, oh, that's not going to get me there. Try a different method. That's the kind of stuff that I expect you guys to be able to do. It's okay to struggle through this stuff. It's okay. This stuff is hard, and that's fine. The idea is that if you get roadblocked one way, try different. Like I did here. I saw secant tangent. I'm like, oh, try sines and cosines. That's one method that we've done many times. Tried and I realized it didn't get me anywhere, so I tried a different method. Conjugates work. You can anytime. Okay, it's worth a shot to try it. So if you've got a 1 plus a cosine or a 1 minus a secant or a sine minus 1, whether it's numerator or denominator, give it a shot. See what happens. It might, in fact, get you to where you need to go. Same thing goes for rewriting things as complex fractions. It doesn't hurt to try, because then you get common denominators, and a lot of times when you get common denominators, you wind up with Pythagorean. Okay? So there's multiple methods by which all of this stuff goes. Every one of them, it's kind of like fair game. It's the idea that it's okay to struggle to find the method that works. All right? And that's what's weird for a lot of you guys to have to go through. So what I have here is basically every other set of problems that I had. did I give you that many? I didn't mean to.
We do
Yeah.
We have not.
Now, obviously, I don't expect you guys to go through 16, 34, 54, geez, 54, 90, 106 of these. But there are 106 of them here. Yeah, they're all due tomorrow, ladies and gentlemen. Good luck. And by the way, there's updates available if you need them. No, what I would do, there's a couple of them on here. You see ones that have square roots to them. Avoid them. You don't need those things. But a lot of them, there's simplified, there's verified. I think most of these are verified, to be honest with you. So at least you know what your answer is in the end. Yes, sir. The test on the entire unit is next week. I'm shooting for Thursday. Okay? Because then tomorrow, like I said, tomorrow I'm giving you guys either 4 or 5 simplified, verified style problems. Okay? The Friday then we will do our equations, and we'll do equations Friday, probably Monday, Tuesday we'll finish it up, and then Wednesday, big old review over everything non-calculator. We'll take the test on it on Thursday that we've got a buffer day in case somebody's dead and they have to come in on Friday and take the test course for break. Woo-hoo! We will, yeah.
Early like that.
Strike faster. Catch up to them. Leave Friday after school. That's weird. That's a whole you problem, not a me problem right here. This is awesome. Yes, children talking is annoying. Believe me, I know. I'm joking. I'm joking. Good. With this stuff, I'm pretty sure I've got a lot of the solution keys to this stuff lying around somewhere. I'll post as much of it that I have on today's date. That way you can look at some stuff. I don't remember which problems that I have, but I have something somewhere. Whatever, you look like you're gonna die, don't die, you're okay. Bro, that's alright. I hate you too, come on. Such a nice person. I don't care about updates. I'm not gonna update, it takes forever.